So now we're going to go the opposite way. We're going to be looking at the equation of the function and then graphing it based on that. So looking at A, we need to know that what the degree is, what the leading coefficient is, and that will tell us what the end behavior is. Then we can deal with the zeros. So in A, we know it's a degree of 3 because we have 3 factors. We know the leading coefficient is positive because of positive in front, meaning generally speaking the graph is going to make this kind of shape. But we're not going to draw it exactly like that. Just to give us a bit of an idea, we know it's going to have that kind of end and that kind of end. Now we deal with what happens in the middle. Well, we're going to have x-intercepts. One of them will be at 1, another one at -2, and another one at -3. So we can put those on. The behavior of the graph at those x-intercepts is to be just passing through. So ideally, now this arrow right here is actually not accurate, it's just there as a reminder of where that graph has to go at the end. What the graph is likely going to do is going to go straight through at -3. It has to turn around someplace. And we don't know how high it is when it turns around, and to be honest, that doesn't matter to us. It goes back through at -2, it turns around, and comes back through at 1. You can erase those guidelines, and that would be the general shape of that function. Moving on to example B, we've got a degree of 4 because of the 3 exponent on the first bracket and no exponent on the second bracket. Leading coefficient is negative. And we have x-intercepts at -2 and at 4. So because this is an even degree, means it's going to make a parabola-like shape. Leading coefficient is negative, meaning it's going to open down. So the end behavior of the graph will be something like that. X-intercepts, one at -2, one at 4. The behavior of them, the one at -2, because there's a multiplicity of 3 on it, it's going to hesitate as it comes in. I'm just going to erase the guidelines so I have some more room to draw it the way it needs to be. It's going to come up and it's going to appear like it comes to the x-axis too soon. It's going to hesitate and then it's going to go up and through. The x-intercept at 4 has a 1 multiplicity, so the graph is going to have to turn around and go straight through that one. Can erase that last guideline, and that graph would look something like that. Example C, the issue with this is that we haven't actually got this function factored out. We have it pre-factored. So we would need to take and do synthetic division, find our list of possible factors, and go about it that way. To save a little bit of time, and since we've already done that, this would factor into -2, x minus 1, x minus 1, and x plus 2. Which we can be a little more efficient. We can write that as x minus 1 squared. So then our degree would be 3, 2 multiplicity and 1 multiplicity. Leading coefficient is negative because of the -2. X-intercepts at 1 and at -2. Odd degree, meaning it makes basically a line shape. Negative leading coefficient, meaning it goes down from left to right. So our guidelines the function is going to look something like that. X-intercept at 1 and negative 2. The x-intercept at negative 2 has a 1 multiplicity, so the graph can go straight through. The x-intercept at 1 has a multiplicity of 2, so after that graph turns around, it's going to bounce off of that x-intercept and continue going down. Get rid of the guidelines, and that's a pretty accurate drawing of that function.